Hello, in this video I'm going to be showing you how to derive the surface area of a tetrahedron from scratch. Now first of all, a tetrahedron consists of four equilateral triangles. What you see on the screen is the net of a tetrahedron. Each of its edges are of the same length, and we can call that length r. Now you can vaguely see some circles in this diagram. It turns out if you draw the seed of life pattern and you connect some of the dots, you can form this net of a tetrahedron. Now r is a good variable to use because these lengths are actually the radiuses of circles. Okay, so without too much theory, let's get to the derivation. So to get the area of one of these equilateral triangles, what we need to do is split the length r down the middle for one of these triangles. This line over here is a perpendicular bisector, and by cutting this line in half, we can use Pythagoras' theorem to derive the area, or at least half the area, of one of these equilateral triangles. So the surface area of the tetrahedron will be A1 plus A2 plus A3 plus A4 plus A5. But to get everything, let's look at A1 individually. So A1 is actually a right-angled triangle because this line here at the bottom has been split in half by a perpendicular bisector. Okay, so let's say for that A1, the adjacent side is half r, okay, because this line has been split in half. Let's say the hypotenuse is r. What is the opposite though? We don't know yet, and we actually need that opposite to find the area of A1. Okay, so let's call the opposite side x, and let's use Pythagoras' theorem to discover what this value is. A1 is a right-angled triangle, so we can write half r squared plus x squared is equal to r squared. If we isolate x, okay, in this equation, we can find its value. So let's subtract half r squared from the left-hand side of the equation. If we do that, we are left with this over here. Now, what we need to calculate r squared minus half r squared is the same denominator, okay? So let's turn these on the right into fractions. If we do that, we get x squared is 4r squared over 4 minus r squared over 4. This is the same as 3r squared over 4, and if we take the square root of both sides of this equation over here, we discover that x is r times root 3 over 2. Okay, we now know that the adjacent side is half r, and the opposite side is r times root 3 over 2. From here, we can get the area of A1, the area of A2, and the entire area of this net. Before we proceed further though, let's acknowledge that A1 plus A2, these two areas over here, are the same as A3, A4, and A5, okay? And the surface area of the tetrahedron is A1 plus A2 plus A3 plus A4 plus A5, okay? If we can get A1 and A2, we're going to get everything. Now, another very important thing is this. Because A1 plus A2 is equal to all of this over here, okay, the surface area of the entire tetrahedron is going to be 4 times A1 plus A2. Okay, so we get A1 and A2 and we multiply it by 4, and that is the entire surface area. Okay, so let's get the area of A1, which is half the area of a rectangle. The area of A1 is going to be half r times root 3 over 2 times a half, okay? Because this is half the area of a rectangle. Now A2 is exactly the same as A1. It's just a mirror reflection. So the surface area of a tetrahedron is 4 times A1 plus A2. Let's put the values of A1 and A2 inside these brackets over here. For A1, we are going to get r squared times root 3 over 8. And that's the same for A2, okay? So inside these brackets over here, we have 2 times r squared times root 3 over 8. And we're going to multiply that by 4. Now, since 4 over 8 is equal to a half, what we end up with is 2r squared times root 3 over 2. And from here, if we cancel out the 2's, we end up with r squared times root 3 as the surface area of a tetrahedron. Okay, so that's how to derive the surface area of a tetrahedron from absolute scratch. I hope this video has been useful to you. If you have any questions, leave them in the comment section below, and I'll try to respond as soon as I can. For more mathematics proofs, stay tuned to my channel and visit mathematics.proofs on Instagram. Cheers for watching and see you in my next video.